Okay, radians. A radian is a unit for measuring degrees based on the length of an arc in a circle. Now the other unit was degree, wasn't it? So we've been using degrees for angle so far, and now you're upgraded to we're ready to learn radians. So 1 radian is the angle subtended by an arc with a length 1 unit in a unit circle of radius 1. Now unit circle is a circle with a radius 1. So let's have a look at the diagram here. Okay, so that's unit circle. As you can see, radius is all 1, and the 1 radian is this angle here. Okay, and it happens when the arc and the radius is the same, just 1 and 1 here. Okay, so knowing all that, let's have a look at what we can do with them. Okay, so first thing will be we can change them between radians and degrees and swap them around. Now all these things we need to get through before we can actually start solving questions. It's like a cooking, guys. So we're just getting all the materials and, you know, getting ready for real cooking. So how do we get these, how do we change them? Okay, so let's have a look at a circle. So circumference is what? 2 pi r, and r is 1 because it is what? Unit circle. So c equals 2 pi. Now 2 pi equals circumference. So what's the, we can change the circumference into degrees, it'll be what? 360, wouldn't it? Because a full circle, angle of full circle is 360. So therefore, I can say pi equals 180 because it's half of that. So this is what we're going to use. Okay, pi radians, pi radians equals 180 degrees. Okay, so that's radians, because what was the radians is about? It's the angle subtended by an arc, isn't it? That's why we're using circumference. So it's all about arc, that creating the angle. Okay, so then I've got 2 questions for you. I don't know whether you have this already in your mind. How big is 1 radian in degrees? I was just wondering, you know, how big is it? Like physically, I want to know. So let's have a look at that. So if I want to know 1 radian, so I know that pi radians equals 180 degrees, yeah? So if I want to change into 1 radian, I can just have to divide by pi on both sides, isn't it? That, it'll be pi divided by pi will be 1. So 180 divided by pi. And that, put that in your calculator, 1 radian equals about 57.3 degrees. Okay, so that's how big 1 radian is. And then you might ask yourself, how many radians can fit into 1 circle? You know, how many radians? Yeah, well, that's easy, isn't it? You just know how many 57.3 can fit into 360. So if you do that, you probably get 360 divided by 57.3. Roughly, you will get 6.28 something. So you will get just over 6 radians can fit into 1 full circle. Okay, just a couple of questions. Now, there's a couple of formulas you might like to use or memorize if you want to convert degrees to radians. Now, how do I memorize this easily? This is what I do. I'm sure you will have another way of doing it. Now, this is what? Degrees to radians. So degrees, I'm just going to say 180 degrees, and then radians is pi. So think of this as going from denominator to numerator. So it's going to go 180 to pi. So I'm going to go 180 to pi. So whatever degrees you got there, you times by pi over 180. And then the other way around, whatever radians you got, you're going to go pi to 180. So it'll be pi to 180 degrees. Okay, so think of that. Before we jump into the question, I would like to do some exact ratios in radians. Okay, now I've done this in the previous trigonometry videos, so if you want to go and have a look at that, that would be great. I like to do it 30, 60, 45 instead of do 30, 45, 60. But anyway, I'm going to change this one to radians first in pi form. So 30 degrees is 180 divided by 6. If you don't believe me, just put that in calculator, you'll get it. And then pi over 3, pi over 4. So now memorize this. So sine pi over 6, sine pi over 3, sine pi over 4. That's how you actually have to say it from here on. The pattern is, just watch me carefully. So what happened is there's a pattern there, like a half, half, 1. Now remember, sine and cos are like friends and cousins, and so they swap around. Sine, cos, you know, are very similar. You can see that with sine wave and cosine wave, because cos wave is just like shifting sine wave a little bit. Anyway, back to this, and I will do this the same. Now here all the denominator is over 2. Okay, so this is almost like a half plus half equals 1, sort of like that. And the other one is you have to memorize root 3 over 2. And this is special, but it looks a bit like half plus half equals 1, but it's got square root on the bottom. Okay, now 30 is smaller than 60, so it'll be 1 over root 3. So remember 30, so it's a 3. And this one is root 3, just root 3. So 60 is bigger than 30, so root 3 is bigger than 1 over root 3. So this is how I remember things. So we are, I think, ready to cook. Let's do it. So if you can see the question, that'll be good. Let's have a look at that. I'm going to convert this pi over 3, which is in the radians, to degrees. So we're going from radians to degrees, isn't it? So I'm going to times by the denominator first and numerator, okay? And then I'm going to go pi over 3 times it. Now when you do that, your answer will be, what is this, 60 degrees. Put that in your calculator, 180 divided by 3, because pi will cancel out, will be 60. Yes, that wasn't too bad. Now this one, convert the other way around. We're going from 180 degrees to pi radians. So I'm going to times this by 180 goes on the bottom, pi, and then 50 degrees. So put that in your calculator. I'm going to show you your calculator. Okay, if I can see you better. Okay, so I'm going to turn on the calculator, put it in a decimal, and I mean fraction, and 50 pi over 180, and I will get 0.87 because it says 2 decimal places. So my answer is 0.87. Excellent. Now this is an interesting one. Now you might say, oh, cos 1.145. I haven't seen that one before, because normally it's in degrees, isn't it? Cos 30 degrees or cos 180 degrees or something like that. Now it's cos 1.145. Now it's in radians, okay? This is in radians. So when we calculate this, we need to change, okay? Can you see that that's degrees? We need to change that into radians. So what I'm going to do is, you've got to do shift and mode to go to setup, and you have to press 4. So can you see that it's changed into R? So now all the calculation will be in radians. Okay, so what I'm going to do is now cos, it was 1.145, 1.145, put that in, press that, I will get 0.41 because I want it to be corrected 2 decimal places. So I'm going to go, that was roughly 0.41. So remember, guys, to change it to radians. Now I want to change back to degrees. I'll use a shift mode and then go back to 3 equals. Now, as you can see, the answer is completely different. So if you use degrees where you're supposed to use radians, you will get a wrong answer. So make sure you don't do that. Okay? All right, next one. Let's do this all in one go. I think we can do that. Okay, so let's have a look. Sine pi over 6. Pi over 6. Now, anyone remember pi over 6? Pi over 6 is a 30 degrees, and that's half. Okay, so if you don't remember, pause this video and memorize them and come back to it. Sine pi over 3 is sine 60, which is root 3 over 2. Sine pi over 4, sine 45 is 1 over root 2, or you can do root 2 over 2. It's up to you. Cos pi over 6 is a cos 30, which is the root 3 over 2. And tan 45 is, well, pi over 4 is 45, so it's 1. Tan pi over 3 is what? Tan 60, which is bigger. So that's what it is. Okay, well done, people.